Now, I'd like to introduce Luc Steels. I think Hans-Ulrich has already introduced him, as he introduced everybody on this panel. Luc directs the Sony laboratory, robotics laboratory in Paris. He also works in Barcelona, where they're doing research on, I guess, artificial life. And his research concerns, on the one hand, what he's going to talk about, which is body image, and on the other hand, concerns language. Okay, Luc Steels.
Okay, well, let me thank you first, the organizers, Hans-Ulrich and all his team for this wonderful event. And sorry, can you hear me? Yeah. I'm going to talk about embodied memory. And you could say the species that I work with is robotic species. You know, these humanoid robots, they're small. They can do many things. They're not human, certainly not. I think we just saw a demonstration how stunning the human brain is and, you know, the human mind. So certainly the robots we have today are a very weak reflection, but they are an interesting platform to think about many questions related to memory, related to perception, related to the body, to language. And so this is what I'm going to talk about, is how we approach today, how we are seeking today to create memories for these robots that we try to learn from the way that human memory may function. Now, of course, an advantage of a robot is that we can look inside and we can see everything that's going on. Now, if we do that, then we see something like this. Okay, this is a robot moving, and you see all these wiggles on the screen, different sensors that are coming in, different motors, different actuators, and they're sort of changes in state. But if you look at this, it's a totally bewildering sensory impression that you have. And I guess this is also what we as humans experience with all the sensors, our tactile, our visual sensors. Well, these robots can also look, of course, at other robots or at themselves. And then they have a visual experience. They have cameras. And these images are flowing in. And there's a huge, incredible amount of information that's coming into these robots. And so the question is, what can we do to make sense of all this information? What kind of memory could these robots have so that they can interact with the world and with us? Now, if we talk about memory, as Israel was already pointing out, you know, it's not one kind of a memory. There's a visual memory of our visual experiences that are coming in. And we make a visual image, you could say, also of our own body when we look at it, for example. Now, there's the motor image, which is the way that we control our body, the different streams that we are sending to our hands to our legs and so on to move. Now we also have a conceptual image of ourselves and of our body. And then there's language so that we can talk about it. We can ask other people to do actions. There's the tactile image, which we just heard in this fantastic talk. You know, how when visual image is shrinking, that the tactile image is actually being enriched because more attention is being paid to it. Then proprioception is the different sensors that are attached to the body that give an experience, how your muscles are moving or how your whole body is moving. There's an internal simulation that you can have where you sort of imagine what the movement of your body is going to be when even without doing it. And of course, there's also an emotional image or a memory that you have of your body. And so we have these different kinds of things, and people used to think that they're quite separate areas in the brain. And in neuroimaging experiments, they sort of, you know, show you images of the brain, which suggests that there are these different parts. But actually, whatever you do, your whole brain is involved. You know, it's not one area that lights up when you move, for example. In fact, everything is lighting up. And this is giving us an important clue, which is that everything in memory has to be connected. In other words, when we think about memory, we have to think about it as a dynamical network, as something that's all the time adapting, is changing, is getting experience, making new links, enforcing them or diminishing them, and so on. So this is the vision that we try to understand when we are trying to conceive of memories for these robots. This is sort of the line that we are trying to take, which is very different from what used to be thought in artificial intelligence and robotics research, namely that memory was more like a computer memory, where you had a store where you put things in a store and you retrieve them when you need them. So this is a very dynamical view of memory. And so all these things are connected. And this image is not so good, actually, because it seems to suggest that there's a box for motor image and a box for visual image. But it's actually more like this. You know, all these words, concepts, motor control commands, visual images, they're all like in one big sea of things that are all connected with each other and dynamically changing. So now I'm going to show you how we investigate this kind of thing. And the first thing that we do, in fact, is try to give these robots a sense of their own body by connecting visual experience of the body with motor control and other types of experience. So, for example, this is a little clip. Maybe this has to be less loud here, where the robot is looking at its own hand, and but at the same time moving this hand around. This is a kind of random movement, and opening the hand here. And at the same time, you see on the right side, there is the internal simulation, so that the robot can make a connection, learn a connection between its internal body model, so to speak, and the visual image that it has. So we cannot program these things. You know, they have to learn them by being in the world, by moving their body, by looking at it themselves. They can see that. Here is another experiment of the same sort. We put a robot before the mirror and let it do motor babbling. And these are different internal models that I talked about. This is what the robot is actually seeing through the camera. To the right of it, you see a segmentation of the body so that you can apply various algorithms for pattern recognition, so that, you know, there are features of the visual image that can be detected. Now on this, at the bottom side here, you see the proprioception, that is the experience that the robot has through the motors of its own movements. And in still continuing, you see on the top left side, you see the motor control commands that the robot is giving to itself. And here is the internal simulation that the robot is making. So with these experiments, we try to create these webs of relationships, you know, this network connecting all the different dimensions that you might have, tactile and visual and motor control and so on. What we're also doing is we let these robots play language games with each other, because I think, as you also heard in the previous talk, you know, the memory we have, the images we have of our own body and of others is not just a individual subjective experience, but it's something that we coordinate with others. And this way the experience, which is of course individual, becomes shared, becomes social, becomes collective. And so in these language games, what we are trying to do is to capture this aspect of interaction. And in that way, have a coordination of the images that the robots are building of their own body and ways of categorizing their body. I'm just going to show you one example of such a game. And so you see two robots, and one of them is going to ask to the other one to do something, and then the other one will do it. Now, the trick of this experiment is that they start without any preconceived names for actions or even categorizations of actions. You know, they have to evolve these kinds of languages as part of playing language games. And so, in this case, now, oh, sorry, there's no sound. So one robot asked to do an action, the other robot was doing something, and then he said, no, this is not what I asked, and then is showing the action, which gives an opportunity to the other robot to learn it. And so these robots play these language games, and then as a consequence, they're able to invent a kind of language for talking about their body and for relating visual experiences with their own motor control and the categorizations of it. And so if we look inside the brain of these robots as they're playing these games, you know, you get something like this. So this is now the memory, you could say, of a single robot as it is playing these language games. And you see it's a dynamical network. The blue boxes are words that they have invented for naming actions. And this is visual images of certain actions. These are motor control or behavioral control programs. You see that this network is dynamic. It's forming itself with every interaction. There are changes, and it becomes more and more solid as the robots are playing these games. So this is sort of the general idea, which is very compatible with what Israel has been talking about, and also what we learned in the previous talk. You know, this is the idea that memory is not some thing which is stored in a particular location, you know, just like you would have a drawer with something in it that you can take it out. But memory is something very dynamic. It is changing all the time. It's multifaceted, and it is by the interaction with the environment and, of course, the interaction with other people that the memory is created and dynamically expanded. Now, then there are many phenomena that we know about. Israel already talked about phantom limbs or phantom pain, which is that a body part that no longer exists, you could still have a feeling in this. Or when you have a stick and you start using a stick for going around, you know, this stick becomes like a part of your own body. It becomes an extension, so to speak. So your body image is actually adaptive and can change. There are memory disturbances. There are out-of-body experiences that can be invoked. You know, they're all symptoms or phenomena, you could say, that actually point to the fact that these memory networks, they can be disturbed. And then we wanted to explore this idea. I mean, that's what we're doing at the moment. And there was a kind of experiment. Well, it was not an experiment. It was something something that happened, even if we didn't want it to happen. And so this is a clip again of experiments with robots who are learning their, we are teaching it language, right? Is there sound now coming out? That could maybe move up a bit. Yeah, okay.
Open right hand.
So we asked the robot to do something, and this is kind of
Close right hand.
lesson number 1, for a robot to learn a bit of English.
Open left hand.
And so this interaction between human and a robot. But then while we were doing
Close
this kind of thing,
left hand.
something terrible happened in the sense that, as you will see, the robot got a stroke. Now, this is the first time I'm showing this video clip, because I certainly didn't want to show it to the people who have built this robot, I mean, that would be the end of our
so that was the accident.
the end of our experiment. But
Yeah,
so
but
the,
now, of course, the flows of the
yeah,
program.
okay.
So
But the
maybe
so then
I can try to write
we were extremely worried
That does it.
what would have happened with this robot. Well, how many of the functions would still have been preserved. And so fortunately the robot could still start to move. I mean, this is how it wakes up in a certain sense. It tries its body, and then if it feels safe, it's getting up, and then we can start reusing it again. So we continued our experiments, and then found out that
Open right hand.
yeah. Did you hear?
Open right hand. Try again.
It says no. It cannot do it, right? So there are certain functions that were disturbed after this terrible stroke. And now here we do, maybe I'll stop it here, we do the mirror box experiment. There's a psychologist, neurologist, Ramachandran, who discovered, or at least popularized, a method for people that have phantom limbs, where they cannot move a certain object anymore, and then they feel, oh, it's a lot more than I thought. Okay, so what Ramachandran did was to build a box, a mirror box, where both arms are put, or both hands are put into the box, like you see here on the right side. And so there's a mirror in the middle. And if you look at it from the side, then it is a visual illusion. Because if you then close your one hand, it looks like the other hand also closes, right? And so he uses this, and it's quite stunning, because these patients that feel a cramp in their hand, even if the hand is not there, or if it's not closed, it's just like this, but they feel it. Why? Because there's a disturbance, there's a mismatch in these dynamical networks, because the motor control expects the hand to be open, but then the visual image and the proprioception image are in a clash. And this is causing, well, that's at least one possible theory here, that this is actually what is wrong with it, not the nerves in itself. So it's a system property of this network, right? So, what I did here is we found a mirror somewhere, and try and do this experiment, the mirror box experiment with the robots, to see what would happen. And first it's like, okay, close your left hand. So the problem was on the right hand side. Okay, so that would work, right? That was still working. And then try to see whether the robot would open both hands. What would happen. Okay.
Open left hand. Close left hand. Open both hands.
So before the robot would say, no. But now it does it because of the visual
Close the
experience.
hands.
Well, the other hand, it doesn't open actually, but the robot has the visual experience. And so the network has gained back some of its coherence. So anyway, this is the end of what I wanted to say, which is to make this point, which I think the previous speakers also made, is that memory is dynamic. It's something that is changing all the time, that is being formed by interacting with the environment, looking at your body, looking at mirrors, being touched, you know, seeing where you are being touched, feeling it. And if this is disturbed by some stroke or some loss of a certain sensory dimension, then you have these kinds of clashes that have to be restored. And one way to do that is with visual illusions. Thank you.